Welcome back, students. Let us resume our discussion in section 1. We're doing antidifferentiation. So finding this antiderivative function, capital F of x, or this expression, indefinite integral, and doing this indefinite integral computation, they're the same. And then don't forget this integral constant. Even though I do not take off a point from missing plus c, please keep it there. Oh, missing plus c may not be a deduction, but missing dx, that's a deduction, so remember that. And some rules. Constant rule, addition rule, coefficient rule, and some further warning. Doesn't work for multiplication or division. The power function, add 1 to the power and divide. You can do this for all powers except for negative first power, in which case we have to take the log. And as for this logarithm, if you forget this absolute value sign, it's incorrect, but I will not take off any point. This doesn't mean it's okay. Actually, it is not okay. I'm just being a little bit more forgiving. There may be some other instructors who would take some points off. Exponential functions stay the same. Okay, those are the rules. And then we have some antiderivative problems. We completed this one and that one. Let's resume. How about this? Well, please remember, we can't do this. Product of derivative is not the derivative of the product. Likewise, the product of antiderivative is not antiderivative of product. So we can't do the antiderivative computation for this one and that one separately. Instead, we can FOIL it out. I can FOIL it out. First, 1 times 2, and then outside, and then the inside, and finally the last. All good? Okay. And then let's calculate the antiderivative of each. So this 2 will become 2t. Is that clear? And then next t squared, 1/3 t to the third power, green. And then this minus 2t, minus 2 was there before, add 1 to the power and divide. Of course, you can simplify it into just t squared because 2 times 1/2 will cancel each other out. And finally, this one here, 1/4 t to the 4th power, and then plus c pops up. In this kind of problem, do not change the order when you calculate the antiderivatives. If you do color coding like this, it's great, but if you don't have colors or anything else, at least do not change the order. I know addition is commutative, so you can change the order without changing the value, but writing solution is actually a communication process. You have to justify your answer. And if you switch the order, and then if you cannot track down which function came from where, then you're losing that justification. 70% of the problem is justification, and you're losing that. And of course, the reason I like all those addition problems here is because if you use just AI program, really cheap AI program, or some websites like Mathway or things like those, then it'll scramble up the addition and do some automatic simplification. That means you either copy it, so it's a plagiarism, 0 credit, or at the very most, you have the answer but no justification. 3 points out of 10. So it's between 0 and 3, even with correct answer. So make sure you do not change the any order, and make sure you're using one of these 3 rules. We are using these rules only all the time. Let's see, another problem here, and this one I'll just leave it as an exercise for you. This one is squared, but if you foil it out, and then foil it out, you're going to get a bunch of power functions, and then you can proceed pretty much the same as this. Or you can expand it out with complete square formula, and then you can do it like this. In any case, the detail is left to the students. You can stop the playback and try. Here's the answer key, by the way. Here I use the complete square formula. All right, how about this problem here? We have some fractions, so let's take a little bit higher font, a little bit bigger font. And then how do we handle this? Remember, you can't do this. You cannot take the antiderivative of the numerator and the antiderivative computation of the denominator and then push those two together. You can't do that. It doesn't work this way. Just like we can't do multiplication, we can't do the division. You need some alternative way here. You can separate addition, but not multiplication or division. So you'll have to separate it with addition. How do you do that? Well, here's my suggestion. Separate the numerator. Two x over 3x minus 3 square root of x over 3x. As a matter of fact, it's going to be far more convenient if you have power form, as you have seen here. So let's rewrite this square root of x into 1/2 power. And then you can clearly do some simplification, I guess. So this x and that x will just cancel out. And then we have just x here. And this one here, 1/2 power, first, 3 and 3 will cancel each other out. 1/2 power, and then nothing is there. So first power, you can simplify into negative 1/2 power. And remember, we didn't even start the antiderivative computation. I just did the simplification of the integrand. That's why the integral sign and dx still remains. I didn't do the antiderivative computation yet. I didn't use any of these formulas yet. And make sure you apply all these formulas at the same time. Okay, we got all the simplification done. Integral symbols, dx still stay. And then let's apply antiderivative rule for each. 1/3 was there before. Actually, second power, and then divide by 2. And that's coming from the first term. Makes sense. Now the second term, 2/3, just a constant, so 2/3 x. And finally, this one here, purple, add 1 to the power and divide. That'll complete the problem. Of course, you can simplify. You can rewrite it as 1/6, and then you can rewrite it as 2. Let's see, what did I do in my answer key? Well, yeah, I simplified. 1/6 and 2/3 and just 2. Step 1, separate the numerators. Simplify, get a bunch of power functions added up, and then apply the power rule one at a time. Let's do this one more time. One more time, this time for this problem. I hope we have enough time here. If we don't, then I'll just stop. Again, before starting, let's rewrite this into power form first. So 4 square root of x, I change this into 3/2 power. This one here, I change it like this. Alright, and then let's do appropriate simplification here. Let's separate the numerator. Minus 4x to the 3/2 power divided by 2x squared plus 5x divided by 2x squared. Makes sense? So this one here, blue, and then red, and then green. So that's blue, that's red, and that's green. And then they can be simplified like this. 2 over 2, and then x cubed over x squared. So just x. 4 over 2, so we get 2 as a number part. And then x to the 3/2 power, second power, so negative 1/2 power. Please check if my computation is correct. 5 over 2, okay, all right. That's a number part. And then first power, second power, so negative first power. Please check. Did I do this right? Okay, let's go ahead with an antiderivative computation. Let's put some space in between. The first one, 1/2 x squared. Is that clear? Add 1 to the power and divide. Next, 2 was there before. X to the, add 1 to the power, 1/2 power, and then divide. Did I do this right? Please check. 5/2 is there before, and antiderivative of this, add 1 to the power, and then divide. Oh, I can't do that. I cannot divide by 0, so this doesn't work. It's something else. It's log of x. So that's green. And that completes the problem. So separate the numerator. Okay, all right. And simplify each term. 3/2 power divided by x squared. 3/2 minus 2. 1.5 minus 2. So negative 0.5, negative 1/2 power. But that's not the derivative computation. That's just a simplification. Derivative computation is the next step. Now here, first power divided by second power, so we are subtracting the power, 1 minus 2, so we get negative first power. And then negative first power, that'll give me the log function. So we had been using this one only, and for the first time, we just used this. Let's see, what did I do in my answer key here? Yeah, the same thing. This one is a bit easier to see with color coding. That'll complete section 1.